Welcome everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to comprehend and utilize the inequality symbols, how to graph an inequality on a number line, how to graph a compound inequality on a number line, how to solve multi-step inequalities for a given variable, how to find the slope and y-intercept of a function from an equation, how to graph linear functions using slope and y-intercept, how to graph linear inequalities using slope and y-intercept, and how to use the correct line and shading for graphs of inequalities. How are we learning it? Through the Linear Inequalities Review Notes and the Linear Inequalities Review Assignment. When can we use this information? To determine which scores you can receive on your final exam that will allow you to pass the course, and to calculate the amount of money in a savings account. How do you know you learned it? By getting a score of 4 on the Linear Inequalities Review Assignment. Now let's take a look at our agenda for today. We will begin by going over the learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. After that, we'll go over the Linear Inequalities Review Notes, and then I'll give you time to complete the Linear Inequalities Review Assignment. Once you've completed the assignment, we'll go over it together and answer any questions that you may have. At the end of class, we'll go back over our learning goals and success criteria while you fill out your Before You Go. Your only homework for tonight is to work on any incomplete assignments that you may have. Let's take a look now at the Linear Inequalities Review Notes. The notes begin with the learning goals and success criteria. Now, what is an inequality? An inequality can be of any of these forms. This symbol, this one here. So this one looks like an arrow going this direction, an arrow going this direction. And then we have the arrows with the little bars underneath. And what do these mean? Well, this first symbol means less than. So we have this symbol meaning less than. This one then means greater than. This one means less than again, right? Because that's this arrow. And the bar means or equal to. So this is less than or equal to. And this one, this arrow here, meant greater than. And the bar means or equal to. So it's greater than or equal to. So those are the different inequalities. Now, how can we remember the signs? The easiest way I remember the signs is Pac-Man. So we have Pac-Man here. And Pac-Man's rule is Pac-Man always eats the bigger number. So if you notice, Pac-Man's mouth forms that arrow shape that we just talked about. So it forms the symbol. So if Pac-Man is always eating the bigger number, then we can recognize the way that we can state the symbols. For instance, we have 3 and then this symbol and 4. Well, Pac-Man eats the bigger number, so if I draw Pac-Man on there, I can see that his mouth is eating this side here, which means this is the bigger number. So this number is greater. Well, we always read it from left to right though, so that means if this number is greater, this number's got to be smaller. So we would say 3 is less than 4. Now here, we have 6 on this side, 2 on this side, and if we draw Pac-Man in, there's Pac-Man. Pac-Man, again, always eats the bigger number. So we have 6 being bigger, and we read it from left to right, so we say 6 is bigger than 2, or 6 is greater than 2. So that's one way we can remember the signs. Now, plotting inequalities on a number line. When plotting inequalities on a number line, you must follow specific rules. First of all, for less than or greater than symbols, we use an open circle. For less than or equal to or greater than or equal to, we use a closed circle. And then we shade in the direction of the inequality. So how do we remember the circles? The way we remember it is this. Every inequality gets a circle. And if they add more to the inequality, we add more to the inequality. What does that mean? Well, this is a basic inequality symbol. This is x is less than 4. Well, this is a basic one, so we start with a circle. If they don't add anything extra, meaning they don't add the bar underneath, then we leave it as it is and leave it as an open circle. Now, if they add something to it, for instance, this one says x is greater than or equal to 2. If they add the bar underneath, so if they add something extra, we add to it as well and shade the circle in. So now we know that if there's no bar, we leave it as an open circle. If there is a bar, if they add something extra, we add something extra also and fill it in. So let's look at how we plot these inequalities on a number line. Well, we have x is greater than -3. So first of all, we're going to find -3, which is here, and we're going to decide what kind of circle we need to use. Well, we start with an open circle, and we decide whether we need to shade it in or not. Well, they didn't add anything extra, no bar, so we don't add anything extra either, and we leave it as an open circle. Then we need to shade the values that for x that apply. Well, it says x is greater than -3. So where are all the x's that are bigger? Well, -2 is bigger than -3, -1 is bigger than -3, 0 is bigger than -3, so it's all the numbers on this side. So we would go ahead and shade it with an arrow going this direction, meaning that all of these numbers over here are bigger than -3. Let's look at another example. We have x is less than or equal to 3. So now we're going to go ahead, we would start with an open circle here at 3. And we decide, did they add anything extra? Well, they added the bar underneath. So we will too, and we will come up with a closed circle. Now from there, we're looking at all the x's smaller than 3, right? Because Pac-Man's eating 3, so that means 3 is bigger than all the x's. Well, where are all the x's smaller than 3? Well, they're smaller on this side here, so we would shade in this direction. Now, what is a compound inequality? A compound inequality is two or more inequalities joined together by and or. And what does that look like? It looks like this. 2 is less than or equal to x is less than 6. So that means, what that really means is x is somewhere between 2 and 6. And because it has the or equal to on this side, it can include 2, but it can't include 6. So it's somewhere between them. So how do we do this on the number line? Well, we're going to do the first part. Well, we see that we need to plot a point at -3. So we're going to start with an open circle. And we look at the symbol here. They didn't add anything extra, so we won't either. So we'll leave it at -3. Then we'll go to this one. We know we're going to have an open circle at 4 and check to see if they added anything extra. They didn't add anything extra, so we're going to leave it just like that. And we can see here that x is between those two numbers. So I'm going to shade everything between those two numbers here. And that's my compound inequality on the number line. Let's take a look at another example now. We have -2 is less than or equal to x is less than 5. So we know we're going to have a point at -2, and they did add something extra, so we will too, so it's going to be a closed circle here at -2. And we're going to have a point here at y. They didn't add anything extra, so it's going to be an open circle. And based on our compound inequality, we see that x is between those two numbers, so we're just going to shade in between. There's a video here that shows you how to check your work when dealing with inequalities on a number line using Symbolab. So go ahead and watch that video. Let's take a look now at how we can use Symbolab to check our work when dealing with plotting inequalities on the real number line. So we're going to go ahead and place in our box what we want to plot. So let's say we have x is greater than or equal to 3. So we can go ahead and put it in like that, and we go ahead and click go. And notice it says x is greater than or equal to 3, which is what we want. And if we scroll down, it'll solve it for us if it wasn't already solved for. But if we continue to scroll down, it'll plot this on the number line. So it gives us a point here at 3. It's closed in and then shaded to the right. Now we could do this in a number of ways. We could also do a compound inequality. So let's say it was 3 is less than x is less than or equal to 6. We go ahead and click go. It pops up with our solution here. If we scroll down to the number line, now we have an open circle at 3 and a closed circle at 6 and shaded between. So this is how you can use Symbolab to check your work when plotting inequalities on the real number line. Now, how do we solve multi-step inequalities? Well, first thing we do is we solve it the same way we would if it was an equal sign. So if this was 4x minus 2 is equal to 10, we would just move everything away from the x. We're going to do the same thing here. So we'll start by adding 2 to both sides, and we get 4x is less than 10 plus 2 is 12. Then we get rid of this 4. The 4 is multiplying by x, so we're going to undo that by dividing. So 4 divided by 4 is 1, which is just 1x, which is what we want, so just x. And 12 divided by 4 is 3, so we get x is less than 3. So all we did was keep the symbol and treat it like an equal sign. Now what about this one? We got negative 4x minus 2 is less than 10. So we're going to do the same thing. So we're going to treat it like an equal sign and add 2 to both sides. And we're left with negative 4x is less than 10 plus 2 is 12. Now here's the only rule that we need to know when we're dealing with this. So we treat it like an equal sign. However, if we ever divide both sides or multiply both sides by a negative number, we need to flip the sign to go the other direction. So in this case, we're going to divide both sides by negative 4 here. So when we do that, we need to take this sign and flip it and go the other way. So we flip the sign, and we get negative 4 divided by negative 4 is 1, and 12 divided by negative 4 is negative 3. So we get x, and now we flip the sign, so it says greater than now, negative 3. So anytime we multiply or divide both sides by a negative number, we're always going to flip the sign. There's a video here that shows you how to check multi-step inequalities using Symbolab. So you can watch this video to see how to check your work. Let's take a look now at how we can use Symbolab to check our work when dealing with multi-step inequalities. So we go to symbolab.com and we're going to enter our problem. So we're just going to enter in here. Let's say we got 3x minus 4 is less than 6. And we're going to go ahead and click go. And it shows us what our answer is. The answer is x is less than 10/3. And it shows us step by step how to get there. So we can enter any inequality in here and click go, and it will give us what the solution to the inequality should be. So we can go ahead and change these numbers as we want. Now let's take a look at how we graph linear equations before we get into inequalities. So when we graph a linear equation, the first thing we do is we pick out the slope and the y-intercept, and we're going to graph those points. So we plot the y-intercept, which in this case is negative 2. So I'm going to go down 2 and plot my point. Then I'm going to use the slope to plot the second point. So this tells me I'm going to go change in y of 1, so I'm going to go up 1, change in x of 2, so I'm going to go to the right 2, so up 1 to the right 2, and I plot my point there, and then I connect the dots, and now I have a linear equation that's been graphed. Now how does this apply to inequalities? Well, with inequalities, we're going to graph them the same way. So just like we did before, we're going to plot the y-intercept, which in this case is negative 2, so I go down 2 and plot that point. Then I use the slope to plot the second point. Well, this is change in y, so we're going up 1 to the right 2. So we go up 1 to the right 2, plot my point, connect the dots, and now I have my line. Now the difference is we're going to shade where the y values are bigger than the line. So I'm going to look at the y-axis here, and I'm going to see where the line crosses, which is here, and I want all the y's that are bigger than that line. Well, they're all up here, so I'm going to shade that area up there above the line. So the shading is a new aspect of graphing that we need to consider. The other part is what kind of line to use. So similar to before where we talked about the open circle versus closed circle, same thing here. Every inequality gets a dotted line or an open line. Notice there, it's open because there's little spaces in between. So every inequality gets an open line or a dotted line. If they add more to the inequality, we do too. Meaning if they add the bar underneath, then we're going to add to it and make it a solid line. So in this case, we have y is less than x. Well, I'm looking if they added anything extra, meaning that, did they add the bar here? If they didn't, which in this case they didn't, we'll leave it as it is and it stays as a dotted line. Now, here's an example of x is greater than or equal to 2. Now, they did add something extra. They added the bar here. So we'll add to it as well, and we'll make this a solid line or a closed line. So how does that apply to our inequalities? Well, when we graph these, we have y is less than 3/2 x. So we're going to plot the y-intercept first. Notice there is none listed here, so our y-intercept is 0. So I'm going to go here to 0 and plot my point. And my slope is 3/2, so I'm going to go up 3 to the right 2. So I go up 3 to the right 2, plot my point. And normally, I would just connect the dots. But I need to check to make sure I have the correct line, which in this case, they didn't add anything extra, so I don't either, so it should be a dotted line. So there's my dotted line. Now, I just need to shade it. So it says y is smaller than the line. So I'm going to go along my y-axis and find where it meets the line, which is here. And I want all the y's that are smaller. All of those are down here, so I'm going to shade everything on this side of the line. Let's look at another example. We have y is less than or equal to negative x minus 3. So again, I'm going to plot my y-intercept first, which is negative 3. So I go down 3 here. And my slope is just negative x, which really is negative 1. So that's negative 1 over 1. So that means I'm going to go down 1 to the right 1 and plot that point. Again, normally I just connect the dots, but I need to make sure I have the correct line. Well, they did add something extra, so we will too. So we're going to have a solid line. And now we just need to shade the graph. It says y is smaller than the line. So I'm going to go along my y-axis and find where they meet, which is here. And I'm going to look at all the y's that are smaller than the line, which are down here. So I'm going to go ahead and shade this area here. And that's how I graph the linear inequality. There's a video here that shows you how to check your work using Desmos after you've already graphed the linear inequality, so you can check it using Desmos. Let's talk now about how we can use Desmos to check our work when dealing with systems of linear inequalities. First thing we're going to do is go to desmos.com, which is here, and then we're going to go to where it says Graphing Calculator. I'm going to click on that. And on the left side, I can enter the two inequalities that I want to look at. So let's go ahead and put one in. Y is greater than 1/2 x minus 5. So there's my first one. And then I'm going to put my second one in. Y is less than 3x plus 2. Okay, and now we can see where we have our two lines that are drawn. They're both, in this case, dotted. Okay, but that could change depending on the sign. They're both dotted, and we can see that this area up here is all shaded in red. This area here is all shaded in blue, and this area is shaded in purple. The purple area is the part we care about. This is the overlap of the shading. So all of this area here would represent the solutions to the system of inequalities. So, and we could enter this in with any equations, any inequalities, and it will graph it for us and show us exactly where the solution should occur. So that's how you can use Desmos to check your work when dealing with systems of linear inequalities. Let's take a look now at the linear inequalities review assignment. The assignment begins with our learning goals and success criteria. If we scroll down, we can see the questions. The first question says, which of the following number lines represents the inequality below? We have y is greater than 3. Well, we notice they didn't add anything extra, so we won't either, so we should have an open circle. This one has an open circle, this one has an open circle, these two are closed, so it can't be these two, it's got to be one of these two here. And we want all the y's bigger. Where are all the y's bigger? The y's get bigger to the right, so it should be this one here. So we'll continue to answer each of these questions until we get to the end. Once we get to the end, we'll click Next. This will take you to your Before You Go. Go ahead and fill out your Before You Go and then submit your work on Google Classroom.